Sometimes the structure of an object will tell us what it's designed to do. Or what it's not designed to do. Human beings are omnivorous. That means we eat vegetables as well as meat. The structures inside our mouths support that function. Our incisors bite, our molars grind, but none of our teeth can do what a snake's have to do.
Snakes use their teeth like hands in humans to manipulate their food. You'll note that all the snake's teeth are curved towards the rear of the mouth, which enables the animal to grab the prey and pull it down its gullet. Just like barb on a fish hook, they're designed to snag.
Kevin McCurley is a herpetoculturist. He studies and breeds snakes. Most days, you can find him in his shop with his collection of over 4,000 snakes. He knows each one like a friend, what makes them individuals, and what makes them just plain snake.
A snake has to secure its prey without the use of hands. So it has to immobilize its prey, capture its prey, and kill its prey without any limbs.
Don't let go.
Just teeth, constriction, and envenomation.
All snakes have developed specialized structures to perform the specialized functions of eating and digestion, just as humans have. A constrictor snags its prey and then suffocates it before taking it into its mouth. Venomous snakes are different. They envenomate their prey first.
So he's going to sit there and just wait.
The skull of each tells the story.
You'll note that the structure and function of this constrictor, which is an African rock python, many teeth, very, very heavy bones. It's all supportive of a large constrictor that grabs and immobilizes its prey through constriction, suffocation. Here we have a much thinner skeletal structure, but we have very large venom glands. So we have this big area which would just support large venom glands. So we have heavy structure for grabbing and the mechanics of immobilization of the prey just from brute force. Here we have venom.
The fangs of a venomous snake are not teeth, and they perform a more lethal function.
A venomous snake's fang is like a hypodermic needle. The function of it is to bring venom from the venom gland through the venom duct, down the fang, and into the prey item to immobilize and kill it. If you look at the snake's fang, you can see the little slit, which is where the venom will actually leave the fang.
Before food can be eaten, it has to get inside an organism. Jaws are one structure that make this possible. Ours hinge at a 45-degree angle. Snakes have different jaw structures, suited to their carnivorous diet.
Snakes, when they need to, can unhinge their jaw and consume larger prey items. So once the jaw is unhinged, right here, there's a little joint that the animal can manipulate and unhook. Now you can stretch your mouth as far as the skin allows. The upper jaw is more important than the lower jaw because this is used to really manipulate the food item down the throat. Grappling and pulling back and then alternating with the other side, grabbing and pulling it back. They pull it back and each time they've gained more ground on the rodent and they've pulled more of the rodent's body down its gullet.
Snakes have to have another clever structure which humans don't have.
This large food item is taking up basically the majority of the animal's mouth and it's making it very hard to breathe. So they have something located in the lower portion of their jaw. It's called the glottis, which is actually a breathing tube, like a snorkel. There you can see the glottis right there. See the glottis? The glottis at work right there.
Now that the prey is past the mouth, the jaw that's been unhinged needs to be rehinged.
Working his jaw right there through a yawning process and then side-to-side motion. It just basically locates the rudimentary joint of the jaw back into location.
Once food passes through a snake's mouth to its esophagus, its digestive system is remarkably like ours. Lining our and its esophagus, strong internal muscles move food to the stomach by the action of peristalsis.
Oh, look at that. He's just posing for you.
Food arrives at the stomach, and there we do differ. In the human stomach, muscles contract to quickly mix food with acid and enzymes. Snakes have to wait for the food to be slowly broken down. Until it is, they are vulnerable.
If the animal has a very large meal in it, and let's say it encounters a large, formidable predator, this large food item in its stomach is going to be a hindrance. So if that animal really has to, it has the ability in short time to actually regurgitate its entire meal. It's a bit stressful for the animal, but the animal has this way as like a last, ditch effort to get away.
The environment provides all living things with the food necessary for survival. Specialized structures adapted to the environment make that food available. Sometimes we can tell what a structure does just by looking at it. How are these structures especially suited to the function of getting and eating the food these animals need?